Hello everyone. Let's start with the topic relations and functions. Yesterday what we did, we have done for our function part kinds of function, one function, onto function, many one function in a pictorial form. Yesterday it was with the Venn diagram. Now let's move with some algorithm approach for the one function. Now here I am writing some steps. Algorithm approach for one function. Now for one function, what yesterday we did? Yesterday we were knowing that for one function, if we are having these elements, then it can be like this. This is also one. If E is not here, then also it is one. And what it was when we are having 1 with A, 2 with B, 3 with C and 4 with D, E is not there, 1 onto. That was one onto function. Now we are moving with an algorithm approach for a one function. Now step 1 is for x1 x2 belongs to A, any set, put fx1 is equal to fx2. Now we have to put fx1 is equal to fx2. Then step number 2, solve the equation. I am going to give you few examples also, and then with the help of the examples you can proceed the steps. And step 3 is for, or you can say after solving if we get x1 is equal to x2, then the function is 1. You can write like this also, 1. Now these are the 3 steps for a one function. Now how we can solve it? First of all, let me tell you what x1 and x2 are. For example, we are having a function defined from a set of real numbers. We are having, suppose fx is equal to, let it be 4x. Now you are taking x1 and x2, x1 comma x2 both are belonging for a set, let it be a, and one more thing, basically x1 should not be equal to x2. It can be x1 can be equal to x2 also, because then we will getting the same results, and that was a equal function. Okay, so now we are having 4x. Now we have taken x1 is equal to 1 and x2 is equal to 2. Now what the result is? We are having f1 is equal to 4 times 1, that is 4, and f2 is equal to 4 times 2, that is 8. So for 1 and 2, now if we are making a diagram here, 1, 2, what the result is? That is 4, 8. So this is a one function. So basically this means put x1 and x2 in your question. Now let's move with another example. We are having, now suppose we are having a function. Now I am going to give you 2-3 different types of examples. Just go through it. Now number 1, let it be example number 1. Example 1 is a function defined from a set of a real numbers such that fx is equal to 4x minus 7. Suppose this is the question number 1. This is the question. It is 4x minus 7. Then what we are having? Step number 1. Step number 1 is For x1, x2 belongs to A, put fx1 is equal to fx2. Now I am writing, when I am writing fx1 is equal to fx2, now this means what? I have to write 4x1 minus 7 is equal to 4x2 minus 7. Now second step is solve the equation. This equation we have to solve it. Now what this equation becomes? 4x1 is equal to 4x2, because this 7 moves to that side, or you can say both the digits of the both with the symbols, with the signs are same. Minus 7 and minus 7 they cancels. So we are having 4x1 is equal to 4x2. Again 4 and 4 cancels. We are having x1 is equal to x2. So now third step is, after solving, if we get x1 is equal to x2, then our function is what? It is a 1 1 function. So this example moves with the 4, if fx is equal to 4x minus 7, it is what? It is 1 1. Now I am going to give you another example, and remember the steps what I have written on the blackboard. Now the question is, a function from set of real numbers to real numbers is defined for fx is equal to, let it be x square minus 7. Now let's check it, x square minus 1. The first question was with a single degree. That was 4x minus 7, 4x plus 7, 4x, whatever you want to take it. Now one more thing I just want to tell you, whenever we are taking with the square part, neither to be confused, because suppose we are having x square is equal to y square. Then what we are writing? Don't write x is equal to plus minus y. And result should be y is equal to plus minus x. Now this is a wrong part, this is a right part for this basic part. Now y, let's move it with the n again. Now here, if we are taking x, suppose we have taken here y is 4. So we are having y is 4. We are taking x is equal to plus minus y. It means when we are having 4, it is minus 2 plus 2. So this is not a function. For this part, when we are taking minus 2 and 2, 4 is the result, this is a function. So that's why always we have to take this part. Now moving towards the question. Now what is the first step? First step is, step first was put x1, x2 as they are belonging to any of the set. Suppose it is from set A, then we have to write it fx1 is equal to fx2. Now I am putting this part here. We are getting x1 square minus 7 is equal to x2 square minus 7. Now second step was to solve it. Now step 2. Let's solve this part. We are having x1 square minus 7 minus x2 square plus 7 is equal to 0, and we are left with x1 square minus x2 square is equal to 0. Now one more thing. Sometimes it is just many times students, you are just want to complete your exam, your question papers too early, or alternatively the thing is that you want that the time, how to save the time, so you are just doing in a rash manner. What you are doing, you are writing x1 square is equal to x2 square, then you are writing therefore x1 is equal to x2, because this 2 and 2 cancels. No, that is a wrong method. Never to do this part. Okay, so that's why I have written in this manner, x1 square minus 7 minus x2 square plus 7 is equal to 0, and now we are getting x1 square minus x2 square is equal to 0. Now who is going to tell me the identity for a square minus b square? Yes, good. So it is x1 square minus x2 square, we are getting x minus 1, sorry, x1 minus x2 and x1 plus x2 is equal to 0. Now the identity for a square minus b square is equal to a minus b into a plus b. Now here we are having this part and this part are equal to 0, either this is 0 or this is 0 or both are 0. So we are writing x1 minus x2 is equal to 0 and x1 plus x2 is equal to 0. Here we are having x1 is equal to x2 and here we are having x1 is equal to minus x2. So what the result is? The result is this question. Which question? Which we are solving. This question, this is not a 1-1 function because we are getting x1 is equal to x2 and x1 is equal to minus x2. Now what this shows, as we have drawn a diagram earlier also, they are showing that a single digit, suppose this is x1, x1 is equal to x2 and x1 is equal to minus x2. This is x1, x2 and this is minus x2 and this is x2. So it shows like this, that x1 is equal to x2 and x1 is equal to minus x2. So this is not a 1-1 function. Okay. So now let's move for the algorithm approach for onto function. Now I am writing here algorithm approach for onto functions. Again, first I will write the steps and then I will show you how to solve it. Algorithm approach for onto function. Now again, step number 1. Step 1 is put fx is equal to y. Step 2 is, you can write it step 1, put instead of writing step 2, I am just taking it in the short form. Put fx is equal to y and solve it for x. Put fx is equal to y and solve it for x. Step 2, let x in terms of y be given by x is equal to gy. If for any y belongs to b, we get value of x where x belongs to a, then this function is onto function. Onto function. Now just go for this algorithm approach. I have written put fx is equal to y and solve it for x. Let x in terms of y be given by x is equal to gx. You can write in place of gx any function. Then if for any y belongs to b, we get the value of x belongs to a, then this function is a onto function. Now again example. Now in the example we are having a function from set of real numbers defined as fx is equal to, you can write here any type of algebraic expression, whatever you feel. So I am just taking it as a 13x plus 9. I told you can write it with the first, what we did in the 1-1 function, it was with a single degree. So again I am writing this question with a single degree. Now we are having fx is equal to 13x plus 9. Now how to proceed it? As we have written here, let, for here I am just changing it, let x in terms of y, it's alright. Let y be any real number for example, we are writing fx is equal to y. You can check it. Let y be any real number where fx is equal to y, and what this implies? This implies, what this implies? This implies 13x plus 9 is equal to y. Written 13x plus 9 is equal to y. Now check it, what we have written. Put fx equal to y and solve it for x. I have written solve it for x. Now let's solve it. This basic part. Now we are having 13x plus 9 is equal to y. Here we got it. 13x is equal to y minus 9 and x is equal to y minus 9 upon 13. So our first steps completes. Fx is equal to y, solve it for x. I have solved it for x. We are having x is equal to y minus 9 upon 13. Now we can say y minus 9 upon 13 also belongs to R. We are getting that this belongs to R. Now then further, a function from y minus 9 upon 13 is equal to what? Now earlier we are having fx was equal to 13x plus 9. Now fy minus 9 upon 13 is equal to 13 times y minus 9 upon 13 plus 9. Now in place of this x I have taken y minus 9 upon 13. So 13 y minus 9 upon 13, when you are solving it, this cancels. We are left with y minus 9 plus 9 and then we are getting y. Now this shows what? This shows that y is the image, y is the image of y minus 9 upon 13. Therefore function is onto. So this is the algorithm step for 1, 1 and onto functions. Now why I have written, why I have solved these two functions only? Because next we are going to do with the inverse function. And in the inverse function, yesterday also I told you, if a function is 1, 1 and onto, then only we can proceed for finding the inverse part. So we have gone through the algorithm approach with nice examples for 1, 1 and onto function.